All right, I'm here right now with Sarah Goehrke. There's going to be a long reel of me hoping that I say people's last names correctly. But you are the founder of Additive Integrity LLC. You've been in the 3D printing space for an amount of time. You have a very large amount of authority on the subject. A lot of people say really good things about you behind your back. So that's positive. Everyone at Team Neo, obviously spoke pretty highly of you. That's how I came to seek you out for an interview. And Team Neo, actually, Rick Earls and Melinda were actually on the podcast that just came out. So this should be pretty good. So, want to start by tell us a little bit about how you came into 3D printing, your background, and all that.
Sure. I always like to lead with, I have an English degree and a theater degree, so obviously I work in 3D printing. Like most people who have been in this industry for more than just a couple of years, I wandered in pretty accidentally. Right out of college, I was temping, I worked in manufacturing for a little while, and then I found a great job editing and then writing market research reports. And just when I was ready for a new thing, after about 6 years in that position, I was applying everywhere, so I almost worked at a tire company, at a restaurant holding company. But one listing that was really attractive to me was hiring for a remote writer and editor for an online news site. And there wasn't a lot of detail, but I was like, I write, I edit, this sounds great. And it turned out, as we got to know each other, the site was 3dprint.com.
Okay.
And that was in October of 2014. So I was the site's second full-time employee who wasn't one of the founders or their family. And they'd just gotten an investment, were looking to grow, make sure the content was good and had that editing. So I kind of just walked in and it's like, great, a writing and editing job. And it turned out it was 3D printing. And within a year of starting there, they sold the site. And I stepped up to become the editor-in-chief. And it was really quickly after that I realized, this isn't a job, this is a career. I love this. I love it so much. As soon as I started traveling, which I do a lot of, there are a lot of shows, events, all of these massive things around the world. And as soon as I got on the ground and started seeing the installations, talking to the people making things happen, I could see their passion, see that there was a lot to this technology that I'd only vaguely heard of before I started all of this. Realized I loved it, and I was like, this is what I do now. These are my people.
What specifically made you love it?
It was really just everything all together. Like, as everything came together and as I started going to these shows, and it was especially the people-focused applications. Like the people who make prosthetics for children. And who are trying to make them better than the conventional ones, like better technology behind it, better mechanics, a better fit for the children, and more affordable for their families. And the fact that that could be made real on something that just kind of spits out melted plastic was pretty rad.
Yeah, interesting, for sure.
And then all of the medical and all of that, but then the fact that it's also useful for aerospace and for manufacturing and all of these places where I did have experience, I was like, oh, this is weirdly relevant to everything.
Yeah, and so you, I guess you report on a more wide scale. So you're looking at applications for manufacturing, but you're also looking at possibly, I assume that you've encountered people 3D printing food.
Yeah.
So it has a very wide kind of array of uses, which has added to a large amount of hype, as we've kind of discussed offline a little bit. What do you really attribute that hype to? And obviously, I happened to read an article that you wrote saying that it should be more boring than it is. So if you want to kind of elaborate on that.
Well, I talked just a couple of days ago to the president of EOS North America, because EOS is celebrating their 30th anniversary. So I had a chat on Friday, I think, with Glenn Fletcher, and he brought up that for him, the hype really started in 2011. It was an article that he read, so he remembers that headline. It was called "Print Me a Stradivarius." And so it was, it was 2011, and a lot of people kind of attribute the main hype time to 2011, 2012 to about 2015-ish. And during that time, it was, oh, print me a Stradivarius. Obviously, you can make the highest end musical instruments that have only been made by masters, but now it can come off a printer. How amazing!
Right.
And so amazing was just this keyword for everything. Like, you can print anything, and you can do it at home. It'll be next to your microwave. You can print food. It'll be instead of your microwave. And there was something to it, because it doesn't come out of nowhere, but it was researchers in a lab who were printing food and working on these things. So it's R&D, but they're taking these, like, futuristic claims and just saying, like, you can do this right now, it's super real.
Right. Well, everyone watches Star Trek, so they want some kind of fabrication device that just says, I want pizza, and then pizza shows up.
Yeah.
And
so it definitely appeals to people, and especially, obviously, we're here in the US, so people like fast, easy, convenient things, and they like super cool things. And so there's a lot that you can say is super cool about 3D printing. It's 3D. I mean, think of like the 3D movie hype in the 50s when you first got the colored glasses. Everyone's just like, this is awesome. I can't watch those movies. They give me a headache.
Now ants are crawling on your skin and you're terrified.
Yeah. So there's always something kind of, like, there's something behind it to create the hype. But then people realize, like, I can't do this at home. This is hard. This is really hard. And that's for, hobbyist level desktop printers, which are hard. Some of them are starter, but there's a lot that goes into it once you get past the ones that, kids can operate.
Yeah, well, I think that also, there's some level of design and CAD expertise that's just necessary if you want to build your own thing. I think that, at least anecdotally, in my experiences, most of the people that are super into 3D printing tend to just download a pre-made thing and they just print it on their printer, but they didn't actually build the specs for it, because there's a lot of engineering that comes into that. Yeah,
there's a huge amount. So once you get past it, and like, you can print everything on Thingiverse and everything that's printable and get what results you will, and some of it's great, but then you're like, oh well, I actually do need a spare knob for my oven, but there's not the file online for my specific oven. And so it's theoretically a really easy thing to do, to just design one and have it done and made and then print it off in your own office. But if you can't design it, you can't do that. Yeah. So the design's just this huge aspect so many people overlook.
Right. And so I guess how does that what are the main differences, and I assume there's a lot, between like home 3D printing and like 3D printing for manufacturing? Because obviously in manufacturing you have a team of actual CAD experts or engineers building something versus home, but is it a similar process all in all?
It depends what you're making and what you're printing with, because like desktop printers are becoming pretty ubiquitous, so those are what most home printers will have. But pretty much every manufacturing facility also has just an army of desktop printers too that they use for everything. Like initial prototypes, tooling, really quick things, replacement knobs. So desktop printers are everywhere. Like, there's a huge market for them, including among professionals. But so a lot of the skills are comparable. Like, if you're using the Ultimaker, you're going to be using Cura software. And so that kind of stays across for everyone, but then it's what you're doing and how complex it is, and then what materials you're using. Because even when you're talking desktop printers, there are some that can be very high temperature, and so you can print engineering grade things. But like, there's a difference between having a Mark Forged printer on your desk and having, a very early MakerBot cupcake.
Right. I guess, so what are the main differences between desktop 3D printers and something more industrial?
So much.
Aside from everything, like what are like the highlights? Because I am only moderately literate, I'm only moderately knowledgeable about 3D printing. So
ASTM International recognizes right now 7 different additive manufacturing processes, from FFF, FDM, which is the extrusion based for desktop, all the way up to the industrial ones, binder jetting, all of that, laser powder bed fusion, DMLS, any of the super ones, and then kind of the ones that can be industrial and prototyping and anything else, SLS, SLA. And so each of those processes is incredibly distinct, and then there are differences within those. Like in SLA, then you move into DLP, which can get higher resolution. Then you've got carbons, DLS.
Okay.
And so I hope if you look into 3D printing, you like letters.
Yeah, because there's a lot of acronyms.
Love acronyms so much. And then there gets to be overlap, and there are like 80 names for extrusion based.
Okay.
Because FDM is copyrighted, so most people say FFF. But then I saw a new one, like it was new to me, like last week.
Oh,
and
really?
it was something really similar to FFF, but they just felt like calling it a different thing.
Was there an actual difference, or?
For the most part, no. For those, Stratasys invented FDM, fused deposition modeling, and so they have the copyright or the trademark, and they love their trademarks, as most businesses do. So fused filament fabrication is the non-trademarked FDM, but they're, you can't say the same thing because trademarks being what they are and all that, but they're the extrusion-based process that everyone thinks of, where it's just a little nozzle going around. But even then, when it comes to FFF systems, you've got Cartesian and Delta systems, and then they print differently, and they're oriented differently. So when you're designing, you have to orient the model differently on the bed, which then influences how many supports you need, because support removal is a huge thing in post-processing. And so every single system, and then within each system process, every actual machine made by each manufacturer has its own very unique things that you as the designer and operator need to sort out. So you can do kind of the same part on an extrusion-based machine and then a DMLS metal machine, but the way that you come about it will be just really different, because there's a difference between fusing metal powder with lasers versus extruding it out of plastic.
And a 3D printer that prints metal can only print that specific kind of metal, or is there some level of universal, like, this guy can print iron, but it can also print steel parts, or how does that work?
A lot of the metal systems, we'll say, are compatible with multiple metals.
Okay.
But there are still, metallurgy is a huge need for additive manufacturing, because you just can't print every metal. You can't just take a standard metal powder and throw it into a 3D printer and assume it'll create the same way as it would in traditional like metal casting or foundry. The properties aren't the same. The metal powders need to be made very differently, and like when it gets down into the super nitty gritty, like you can see the micron sized like way that the metal particles are formed, and people are arguing whether it's better that they're all completely the same perfectly round spherical shape, or if they're irregular to make sure it fills in the cracks better.
Okay, interesting.
So there's this whole thing in that. But that all said, a lot of the metal systems, the industrial ones, are compatible with multiple metals, but in operation will often be dedicated to one, because so many of the metals have really specific operating environments, and if they need an inert environment, and they do best with argon gas for that, or they do best with something else, or they need to be handled this way, because if you handle these powders wrong, they'll explode. Don't want that. So there's, a complete safety element. Yeah. And then cleaning it, because there are just so many things that go into it. You need filtration and all these things set up, because you don't want to inhale fine metal particles. That's not great.
Usually frowned upon.
As a rule. And if it's not, it ought to be. But so a lot of them will be like in their separate room, even if it's not just a dedicated machine. Some will be in separate rooms to make sure that there's no cross contamination of the powders, and like everything needs to be super dialed into what you're using. Okay.
So do you see in like let's say a bigger manufacturer that's really utilizing 3D printers, they have printers that basically do one job, but they do that job all day? Or are you seeing a lot of like piecemeal, like I just need one of these, or are they using these for mass manufacturing?
Yes. All of the above.
Okay. So it's different based on where you're at?
Because the beautiful thing about all of this is that with the build trays, you can build, like it costs, well, it doesn't. A lot of people like to say complexity is free, but there's more to that. And basically anything you say about 3D printing is a great general statement, but, add 1,000 asterisks behind it.
So specifically to some of the manufacturers that you've interfaced with, I guess, what is a typical 3D printing environment?
Oh gosh, there isn't one.
There isn't one? Okay, so...
I mean, definitely one of the best that I've been in lately. Material Solutions is a Siemens business out in the UK, and they just opened their new facility in December. So I went out there for the grand opening, and as I was getting on this plane, I was just like, what has my life become? Because I am just delighted to go to this new manufacturing center in the middle of the English countryside. And it was everything I hoped it would be, because it's
really?
just this beautiful, like, brand new facility. And they've got rows and rows of industrial 3D printers. But they've got this whole second floor that, as of the time of my visit, was still empty. But it's set up for automation, so that they'll have these great big things kind of going across on tracks and able to help pick and move things.
Move things around, yeah.
And then they've got, quality control and post-processing and all of the stations. So it's set up really beautifully for manufacturing and just works kind of that way. But at the same time, as soon as we get, in this state-of-the-art, beautiful facility backed by Siemens dollars,
right,
and with these just scores of machines, as soon as we get to the post-processing, the guy says, do you know what our most commonly used tool is? And he picked up a hammer.
Oh, really?
So it's this incredibly advanced thing, but the first thing you do is still kind of whack it with a hammer and chisel.
Huh. Interesting. Where was that? Was in the UK?
Mm-hmm.
Okay, I've seen a lot of facilities just pop up for in Germany that are pretty nice and a little more forward thinking than I'm used to seeing. But again, I'm also sitting in the Midwest, so it's a little different than our West Coast and East Coast. Do you see more of an adoption for like large scale 3D printing overseas, like particularly in Europe, than you do in America, or is it pretty much a global pace?
I mean, definitely Europe and the US are leading the way, market wise and installation wise, but the Asia Pacific region is picking up incredibly. And especially out of Australia, there are a couple of metals companies that are really promising because they have such a background in the mining industry. So the technology is also coming out of there are more geared for mining. Mm-hmm. So they're totally different processes than what we're seeing here for really finely tuned, super detailed aerospace parts, because mining just needs a huge gear and they need it fast and they need a lot of them.
Okay.
So you're seeing kind of just really different technologies coming out based on where things are, but of course they've got applications everywhere else. Sure. It's a really global industry, and it's kind of interesting to see how it's growing, but definitely the US, and don't knock the Midwest. There's a huge amount of 3D printing.
Well, we need it more because we have all that manufacturing, right?
Because we've got that legacy of being the Rust Belt right here. And so now people keep saying that it's becoming the Tech Belt.
Yeah, I know a lot of people that tell me I'm not allowed to say Rust Belt anymore, so we might bleep that out because there's a lot of people who are like, it's the Tech Belt. Anyone that says Rust Belt's going to get hit, and I don't want to get hit, so...
I'll take the hit. So we're talking about the legacy. Like, I'm a Clevelander born and raised. Like, I know where all of the steel things are. I've been to Pittsburgh a lot. Like,
well, I was
cool. This is what we've got.
I was just in... there was it was a Sports Hall of Fame thing for Pittsburgh, but at there they're like, we're no longer part of, we're not just a steel city, we're a tech city. Mm-hmm. So everyone's trying, Detroit, Cleveland, Erie, Grand Rapids, they're all trying to rebrand themselves kind of way. And I'm like, I don't know, that's a big part of your economy.
But that's why it works, because there is this legacy of manufacturing and expertise and people who know how to do it. And when you get into Detroit, you've got the big three, and now all of them are heavily using additive manufacturing.
Right.
But you've got these people who know how to work with all these materials and who know how to build cars and who know what the parts are needed and when you need spare parts. And so those people are now adopting this. And the important thing is that 3D printing fits with manufacturing. Right. It's not going to overtake it. It's not going to replace it. And that's why it should be boring. Like, you just need to kind of figure out where it slots in to your manufacturing operation. It's
an augmentation, not a replacement of your shop, right? And I think that 3D printing largely is kind of the tech aspect of manufacturing. It's bringing tech to manufacturing. I know that well, I guess mine's more from a cybersecurity perspective, but manufacturers aren't always quick to adopt things that they didn't previously have a budget for. Mm-hmm. And I think the 3D printing at least they had a budget in mind for what they needed to do to produce things, right? As opposed to like cybersecurity, which is a whole new like, what is this? I need to pay how much for a penetration test? Like tabletop exercises. I don't. Somebody's gonna hack my CNC machine, like, you know, and then so those conversations are somewhat common. What are there hesitations that the industry still has implementing this? Are there
absolutely?
And what are they that
There's
you see?
still just huge barriers to entry, and a lot of it is because it's new, and new is scary, especially for manufacturing, which at its root is an incredibly practical industry. Everything you're doing is so that things get done. And if you don't know how to do it, and you've got an engineer who's been making something the same way for 45 years, they don't necessarily want to suddenly try to do what they think is the same thing in a different way.
Right.
Because you do need to completely rethink it for additive manufacturing. You can't just drop a CAD file from a part into a 3D printer and expect the same results. You should redesign it to be optimized for the printer. So design for additive manufacturing, DFAM, is a huge, huge focus right now.
Okay.
And so there are focuses, thankfully, rising initiatives throughout education, like through STEM and STEAM education in schools, into engineering programs, excuse me,
Oh, you're good.
and then into education for professionals, training for on the job, a lot of workshops, a lot of courses offered online and on certain campuses, because you need to think differently to think additively. And so certain companies are also even adding entire divisions to help that, to help their customers and potential customers learn how to do that and how to actually adopt it into their workflow and work with them directly, very closely. And that's also why you see rising use of service bureaus and things like that, where there's in-house expertise. And a lot of that's happening even here in Cleveland and Ohio.
Yeah.
2 weeks ago, I went to the Technology House down in Streetsboro.
Okay.
And they're a contract manufacturer, and they've been working with 3D printing since their start. And they still have their very first SLA machine up and running, and they just keep kind of updating it. And you know, they're brilliant, and they're working on all of their technologies they've built up expertise with, so people can go to them and make use of that expertise.
Interesting. And do you see, I guess, so prior to interfacing with Team Neo at all the projects around 3D printing that I've really interfaced with a lot of the people with have actually been like, we're going to 3D print you an ear. We're going to 3D print you, food. Do you see that a lot? Or, I mean, that's kind of, I guess, does it have the same practicality today? Or is there just more of an immediate need for like plastic and steel?
Well, like plastic and metals are happening now.
Yeah.
And they're happening now on a mass production scale, and they're happening now in installations and around the world. Food and bioprinting are both still in R&D phases, and there are very real strides happening, but they're still both pretty early. Because bioprinting is one of the areas where it's really easy to hype, because 2 weeks ago, I want to say, a study came out where researchers from the University of Tel Aviv in Jerusalem printed a heart about that big, about the size of a cherry. It's the size of a rabbit's heart. But they made it with human cells, and it's got all of the internal structures. It's got, just everything.
You can make like action figure sized people
inside. So the plan is to, that was a very small proof of concept, but the intent is to scale that up and ultimately serve as an organ transplant that your body wouldn't reject because it's made with your cells. Because people die waiting for an organ transplant, because obviously those are based on factors very much outside of recipient's control. They're waiting, frankly, on someone else to die and have their same blood type and general size and
be in the proximity where those organs would be shipped to a hospital they're working with.
And so it's not a great way to be.
Sure.
And especially with heart disease being one of the leading causes of death around the world, it's a huge area to look into. And so there's this idea, this beautiful idea, that you can print something just for somebody, and it's made with their own cells. And then, because also anyone who does get a transplant today is on anti-rejection therapies for the rest of their life.
Okay.
Because their body could reject it at any time, like initially or years from now.
So it just spontaneously, it just comes up, I guess.
Yeah, just the body sees it as an intruder and will attack.
Interesting.
And that's for any kind of transplant. So, but like now, kind of where a lot of the intersection is 3D printing is used very heavily in the medical field, but a lot of that is more for modeling, which is still, it sounds maybe less glamorous, but it's still saving lives. Like 3D Systems helped out with this very well-known case of conjoined twins a couple of years ago, separating these babies who were born with their heads fused together.
Okay, yeah.
But an exact medical model showed exactly where each baby's anatomy was, where they could split them, separate them, and they could use it as a cutting guide in the operating room.
Yeah.
So the surgeons had it on the table, so these babies didn't need to be under anesthetic for longer than they needed, and they could go in, know exactly what they were doing. They could practice ahead of time. So right now that's a lot more realistic than just like printing a new
and I know I've been fortunate enough to have my teeth kicked in, so I've had most of my teeth are 3D printed. They were actually the crowns. They 3D printed them and they put them in an hour, so that was pretty cool.
Yeah, I got into it with my dentist. I got a crown put in a year or two ago, and he melts them, and I was just like, there are better ways.
I didn't. I was just happy to have teeth. But I know hearing aids get 3D printed pretty commonly.
Hearing aids were the biggest and first widespread full industry adoption.
Okay.
It was within 500 days.
Really?
The entire hearing aid industry.
They're just like, we're just doing this now.
Yeah, and it's so much better because they can be made for people and it can be made on demand. And, it's an in-ear hearing aid. You don't want it falling out. You want it to fit right, and so now they can do them out of all kinds of materials, and they're pretty rad.
Yeah, I like how that's going. What are other like common like daily uses, or not daily, but you shouldn't want hearing aids daily, but like kind of like a hearing aid or teeth or that's currently adopted, they're currently given to people?
The two biggest are probably hearing aids and orthodontic aligners.
Okay.
So the company Align 3D prints all of their orthodontic aligners, which again, I'm looking back in my orthodontic history and I'm like, where was that when I was 13?
Right.
Maybe I would have worn my retainer more. Like it was still made to fit me and I was still 13, so I still didn't wear it a lot, but as an adult I'm like, my teeth kind of got a little crooked because I didn't wear it. Maybe I should get a new one, and now it'll be 3D printed.
Yeah, I'm sure that, that's all the way it always has been, with technology. You're always wishing that you were, man, if I was, 20 years old right now, I'd be able to get a new jaw.
But orthodontic aligners are huge, and they print them by the thousands.
Okay.
So those are mass production, sent out to people today. Hearing aids are huge. At CES a couple of years back, Formlabs was there, and I sat down with them to have them scan my ear, because now they also 3D print personalized earbuds. Okay. But it was also nice because they just had this creepy little wand that they wiggle around your ear. So it was a weird thing because I'm just on the floor at CES and they're taking pictures while I'm having this thing in my ear. And so, strange experience, but really quick, very easy. And then we looked at it on a computer, and that's when I learned why I can never wear earbuds. I have short ear canals. I did not know that.
Well, now you do.
I do.
Now you do. Did you always just do like the wraparound ones? Or
because I can't wear earbuds. They just fall out. I'm like, how do people like these? These are terrible. It's just like...
Yeah, so to clarify the random comments I made, I've kickboxed many times before to the point where my ear is irreparably damaged. So there was a point where I could use earbuds, and now I can't. So there's hope for me, Larry. That's why I'm like, I just need a 3D printed new ear. My teeth have been kicked in, so I'm not getting into street fights.
I was going to ask, first rule, don't talk about it, right? So.
Yeah, I did get paid. So that made it okay, right? There was an athletic commission involved.
I'm going to go ahead and not agree to that just because this is on the record.
So actually I had one thought that kind of goes back into more of the manufacturing topic, but do you see, I don't see I don't see like the SMB manufacturers or the smaller guys really adopting a lot of these technologies. And that, I don't just mean obviously smart 3D printing, but like also, I mean, they're using equipment from 30 years ago, across categories, even if it's like a Dell, like, 386 processor. Then I'm like, what is this? How are you running? You're running your payroll through a server that's 35 years old. Like, so there's some mentality there that I think that, it's just the nature of the beast. I think that's changing. But where do you see the SMB using 3D printing, or do you just not see them?
I do see them using it, and a lot of times what happens, like it happened to a friend of mine one day. He was just there, and someone threw him a packet, and they're like, "We need a 3D printer. You're the guy now. Figure it out.
Yeah.
Figure out what we're getting. Here's a budget." And then when you figure out what we're getting, you have to figure out how to use it and how to make it.
Yeah.
And that's just like a personal friend of mine who I know through just random real life.
Okay.
But you hear that everywhere. They just kind of pick somebody, and it's often the youngest guy in an office. And they're just like, tech, learn this, and literally fling a manual on their desk. So a lot of times they're just like, we heard this might be important. Let us know if it is. Let us know if we should be using this. And then when it goes well, that person, then starts really educating themselves, digging into resources, looking at things, exploring, enrolling in a DFAM course, doing online training, reaching out, networking, really figuring things out, and then it can make a difference. And I've seen it happen where then that does lead that company to do a big investment into 3D printing for their company, and then it spreads beyond that one guy. Maybe they hire someone else, maybe they grow that, or maybe they did just need it for tooling.
Okay.
Or they did just need it for something. But another thing we're seeing a lot now is small businesses forming around 3D printing, because especially the way that education's working now, there are degrees in additive manufacturing, and they're all pretty new, but now you can study at bachelor's level, master's, PhD.
Yeah.
And so new graduates are forming companies because this is how they were trained, and that's the difficulty with engineers who have been in the field for 30, 40 years. Because they were trained CNC, they were trained all of these traditional subtractive or molding technologies, and so figuring where to fit something into a workflow that is all you've ever done.
And it's already established, and I definitely understand that too.
Because a lot of it, you'll see a lot of use cases coming from 3D printer manufacturers, and a big focus for them is ROI, because investing in 3D printing is not cheap, and it shouldn't be when you're doing it for manufacturing. But investing into all of that, and then the training and the materials and the maintenance, it's not inconsequential when it comes to the bottom line. But if you can have return on investment within 3 months,
is that what you're seeing? Because that's pretty crazy ROI.
Yeah.
Okay. I mean, at that point, I don't.
Not for all of them, obviously.
Yeah, but that's common, I guess.
It's not uncommon.
Okay.
So it's obviously not a blanket.
It's
thing,
medium.
But it is in use cases that I've read from people in case studies. I know Rise has seen, Rise in particular has shared several case studies where it's been a 3-month return on investment, and so that's also when you see a lot of these companies turning around and investing in a second machine.
Sure.
Because if they can save that much and do that much with this, then it can just save so much time. You do less outsourcing. If you need stays for shoes, a lot of companies used to outsource them, and some guy would be making them by hand out of wood and then send them back. But if you can just print those in-house, you can have them the next day instead of waiting a couple of weeks for a wood carver to work with it.
Interesting. Same. Yeah. I mean, the convenience of 3D printing, I think, is felt. That's super interesting that that's happening at that scale. I just can't get over the ROI.
And that's definitely not all of them. Sometimes it'll be a year, 3 years, but I haven't heard more than that.
Yeah, 3 years is still, I mean, depending on what you're doing, a fair ROI for a lot of major companies. So, as far as resources available in the U.S. or even locally to us, how do people get into 3D printing now? Is it all still people are wandering into it haphazardly with English degrees, or?
I did. I wrote an article a couple of months back on Fabaloo about the ways that people come into 3D printing, and I kind of broke it down into 3 main areas. So the first is me. I guess I do this now.
Sure.
Is kind of the first category, where it wasn't something foreseen, it's something, a new job or job duty, just kind of hoisted upon you, for lack of a better word right now. And so it's just something that happened. So it's, I guess I do this now. And then there's, I want to do this now, and looking intentionally for training and for opportunities in 3D printing, because now there are additive manufacturing engineer positions and DFAM expert positions. And so there's willfully setting your course to do that. And then the third one is I was trained to do this. And so that's today's students who are tomorrow's workforce and actually have that background. This is what they're growing up with now.
Mm-hmm. Yeah, I know Tri-C has a, like locally there are a couple colleges that have a couple programs that are kind of grooming people into those roles. Have you had any experience with those, or have you seen into them to see like what flavor of legitimacy they have?
It's funny, like at TCT show 2016, I want to say, over in the UK, was the first time I met someone with a master's in additive manufacturing. And I was just talking to a bunch of people, and that was also a weird moment for me, because just personally, I'm the youngest of 4 daughters. I was the third youngest in both of my graduating classes. Like, I'm used to being the young kid on the block. And as I'm in the circle talking with 5 or 6 other people, during the networking part of the show, I realized I was not only the oldest person by about a decade, but somehow at that point I'd been in the industry 2 years, but still, like, then with that I was also one of the less experienced people. Like, this 22-year-old kid had a master's in 3D printing and had started a company. And so I was just like, this is just what the workforce looks like now. It is young and it knows what it's doing. And so that was kind of really cool. But I've also, like, education's really important to me, so I've been working with some different people to look into their courses and talk about them and get word out. And so right now I'm also helping to develop a course that'll be coming out within the next year.
Through like a Coursera kind of website?
No,
or
through SME.
SME, okay.
So it's a big legit course, and we had an on-site in New York City in December to talk about one. I'm working with them on a second one.
Yeah, that's awesome.
So it's really just wonderful to see it grow. And then, of course, there are a ton of industry experts who are working with different organizations to create things. So Protolabs and MIT developed a course. Now Terry Wohlers and his team at Wohlers Associates are working with a couple of different avenues to create courses and expand training. So it's really getting out there.
Interesting. So I guess, and I think that 3D printing, along with any kind of like emerging technology, cybersecurity is the one that I'll reference. Mm-hmm. There's not only do you have to create courses for the new workforce, but you also have to find a way to re-educate some of the older or some of the people that are in the middle of their careers. And what they know isn't necessarily the world today, but they still have another 20 years of work left in them. Is this kind of an effort is there an effort to help some of those more seasoned members of the workforce get involved or re-educate themselves without necessarily going through a whole college course, or are there certifications? Because that's kind of the route IT goes, where they're just like, hey, you need the 2019 certification on how to do this, right? Mm-hmm. Is that the same way for 3D printing, or not quite?
Certifications are still developing, and there are a few initiatives, so it'll be, I think, a couple of years before things really shake out and we see which ones become standard. But they are in development, and there are definitely on-the-job training courses for working professionals. And a lot of it's online, mm-hmm. and a lot of it, or they'll do like workshops in a localized place so that you can also get hands-on, because it's one thing to see something on the computer, but it's another thing to really get in there.
Right.
Or get up to your own computer and actually be designing something.
Sure. I'm a classic case of somebody that has passed a lot of tests and got a lot of certifications, but when you put me in front of something and tell me to troubleshoot it, I just kind of sit there and cry until somebody helps me. So I definitely understand that. So certifications, I think that's, no matter what the certification is, or a degree or mm-hmm. whatever, you will have that level of, some people really, really know it intimately, like by touching it, and some mm-hmm. people read a book and regurgitated on a test.
And you see that, and also a lot of companies are offering webinars that are really handy, and a lot of them are free, so anyone can access them. Like through Fabaloo, we partnered with Rise for one of their webinars
Okay.
and kind of talked about production applications. So their CEO, Andy Calambi, and I did a joint presentation about production applications. So I talked about the trends and some uses we're seeing, and Andy spoke to how Rise has been rising to those.
Oh, wow.
I like speaking in puns.
It's okay.
It's fun.
This
for
is
me.
a punny show, so. Yeah, that's. I guess as far as like the certifications and the unknown, if I were to try to hire somebody for it, what would I look for?
I mean, at this point, I'd say experience more than anything,
Yeah.
or even kind of interest, because it's all so young still. It still
Sure.
takes a special kind of person who's really willing to do the work, because it's work. It's a lot of work. It's a new young industry, and
Yeah.
there's so many different initiatives popping up everywhere, because it's a complete end-to-end business rethinking, because it's digital production, which includes design, supply chain, IoT integrations, just everything, IP protection.
Right.
Like, you have to think about all of it. So 3D printing is not just what happens on the printer. There's all the pre-processing that goes into it, all of the post-processing, and then what happens after that.
Yeah. Have you talked to anyone from Hitachi Vantara at all and their IoT integrations with 3D printing, or?
I have not.
Okay, I was just curious. They were working on something. I didn't understand it. I was like, maybe you understood it. We don't understand it, so that's okay. Is there? I guess as we're kind of edging towards the end, is there anything you want to particularly plug, or is there something you want people to know? Do you want people to find you and give you money? What I guess how, or is there anything else you would like to say?
I will say that definitely what has become the dearest mission to me in all of the work I do, because it's 2019, no one does just one thing. So I've got, I think, 3 official titles behind me right now. So I'm the owner of Additive Integrity. I'm the managing editor at Fabaloo through a partnership with Additive Integrity. And then I'm on the board of directors of Women in 3D Printing, which is something I feel so strongly about, because women are still a significant minority of this industry, and so focusing on the diversity of it, and not just women, but educational levels, cultural backgrounds, educational, like anything. People who think the same way will keep thinking the same way. So you need more diversity at the table. And that means more women, that means more minorities, that means more people from trade schools as well as four-year colleges. And so for Women in 3D Printing, I write a semi-annual report called Diversity for Additive Manufacturing, so we can play on DFAM. So we published the most recent one on International Women's Day this year, which was March 8th. So that's available for download now. It's free.
Yeah, I will have a link to everything that we're talking about.
And it used to be a quarterly report, but since statistics are still so hard to find, and I'm sourcing everything through surveys, so I would love it if people responded to our survey, which is available at womenin3dprinting.com.
Send me that link, and then I will put that link out there.
Perfect. So we'd love more data and more experiences. Women in 3D Printing publishes a weekly interview with a woman in the industry. And the beautiful thing is there's this huge backlog of women's interviews that are piling up, and then more people to reach out to, because there actually are a lot of women in this industry, but it's still so few compared to the men.
Yeah, it's hard to outnumber white dudes.
I wasn't gonna say it.
It's okay. I'll be honest. I was very happy to get another woman on the show, because it is very difficult to just find them out in the wild that are really speaking and interfacing. Not that they're not in the field; they're just not always jumping out at you.
It takes more effort, but it's worth the effort.
Yeah.
And Women in 3D Printing also does offer a database of female speakers who are available throughout the world.
Yeah, I will parse that database.
So it's done by geography and expertise that people are available to speak to.
Yeah, that's super important. I think that Cleveland has a couple good groups in particular, but I know a lot of groups in Boston that really try to get women in tech, women in just 3D printing, software development, all of that. So anything that kind of pushes that forward, I think, is definitely what we're trending for in a very positive way.
And it's great because the Women in 3D Printing global community, is obviously very open. We want everyone involved. So we've got a bunch of men who are incredibly supportive of all of this, and we need the men, we need the women, we need everyone in the same room sitting at the same table. And so Women in 3D Printing is also active in, I believe, 35 countries with 75 local chapters that each host a monthly meetup that's just casual. Sometimes there are speakers, sometimes it's just happy hour, but to kind of get to know some of the local women in 3D printing.
Okay. Yeah, cool. We'll put links to that. Obviously, I won't go to that, but
You're very welcome.
Oh, am I? Is it
welcome.
Is it not? Okay, I thought it was a woman only thing.
Nope.
But
we want everyone there.
Okay. Yeah.
It's the whole industry, and
we'll try to get everyone involved. Yeah.
So, and there's also Rapid plus TCT is coming up next month.
Yep.
There will be a Women in 3D Printing happy hour, also open to everyone.
Okay.
And those events are great. We had a huge turnout at FormNext.
Okay. Yeah.
So it's just really cool because once you get everyone together, you're like, oh look, there are actually women in this industry.
Yeah. Yeah, that's I mean that's huge because there are. It's just that they're not. I don't know if they're not even as vocal. They're not as represented, I think, as speakers. I think that's changing, but like
sometimes there are still a few large events where every keynote is a man.
Yeah, sometimes.
And so we're hoping to see that change, but
yeah, sometimes I go to an event and everyone looks just like me, and I'm like, oh man, this isn't good. But I think that largely it's changing. I think that you'll have differences.
It's a slow change, but it is a change. It's evolving, so the industry is going to look more like the population, and I think that is a wonderful and very necessary thing. And
that's progress.
It is, and I just had another point that was salient, and it is gone.
Let it come back in 5, 4, 3, 2. All right. Well, I really appreciate you coming on. Again, anything that we can do to kind of help push any groups, like if there's something that you end up forgetting that you want us to link, we'll push that out. We'll make sure that we can get as many people that we have outreach to involved. And like I said, I really appreciate you taking the time.
Great. Right. Yeah. Thanks so much for having me.
Thank you.
Always fun to talk 3D.
Yeah. It needs more of it. So
it does.
Yeah. All right. And we're done.